All right, in this example, it says sketch the path of an object moving along the plane curve given by, and I wrote this in vector form, component form. Find the velocity, the acceleration vectors, and then the speed when time is 0 and when time is 2. Then sketch the velocity and acceleration vectors on the curve. Okay, so there's a lot going on here. So I went ahead and wrote out the table. So plugging in -5, -4, -3 for the t values. These are my x and the y components. So I'm going to start graphing this. When t is -3, I get this point at 6, -3. And then when time t is -2, I get the point 1, -2. And then -2, -1. When time is 0, I get the point -3, 0. And then when time is 1, I get the point, it should be -2, 1. And then 1, 2. And that point 1, 2 is when time t equals 2. So that's the other point that I'm kind of like interested in for this specific problem. All right, so if I drew that so I can see the pattern, the direction it's moving. So as time passes, it starts down here, and it's moving along in this kind of path. All right, so I don't need this anymore. So what I'm going to do now is I'm going to find the velocity vectors and the acceleration vectors when time is 0 and when time is equal to 2. So the velocity vector is just the derivative of the position vector, which would be 2t and 1. So this is saying there's a constant y velocity is 1. So the y must be like changing in the positive direction 1. So it's going up. So since that's positive, it's always going up, right? Okay, when time is 0, the velocity at 0 would be 0, 1. So the velocity vector, the way it's moving, when time is 0, look at that point, the blue point. So as it's moving along this path, this blue dot, at that moment right there, the x direction, the x component is not moving left or right at all. But the y component is getting bigger. So it looks like the x is going to the left. At that moment, it starts going to the right. So it looks like the x is changing direction at that point. So bringing back something we remember from position, if velocity changes signs, the particle changes directions. So the x changes direction. It looks like the y is just constantly going up. It's just positive 1, so it's moving up. The acceleration is derivative of velocity, so it'd be 2, 0. So what this is saying is the rate at which the y component, it's not changing. It's just going to be 1. It's moving up at that rate of 1. So the velocity at 2 is equal to, what would that be, 4, 1? So what that's saying is at the point 4, 1, that red dot, the x number is positive 4, so it's going to the right, and the y number is 1, so it's going up at that rate of 1 unit per whatever unit. All right, the acceleration at 0 for when t is 0, it doesn't matter, still 2, 0. And acceleration at 2 is also 2, 0. So what this is saying is the rate at which the y component, went from 1 to 1. It's constant, so it's not changing. That's why acceleration is 0. But the x component, it's 2, so it's going faster. It's increasing. The speed is increasing. Now the actual speed, remember speed is the absolute value of velocity. So I'm going to say speed, or it's the magnitude of velocity, is equal to the magnitude of velocity at 0. So it's the square root of 0 squared plus 1 squared, so it's just going to be 1. And then the speed at when time t equals 2 is the magnitude of velocity at 2, which is going to be equal to the square root of 4 squared, which is 16, plus 1, so square root of 17. So let's actually see. So the speed is the magnitude or the length of that velocity vector. So the velocity vector, let's use yellow. The velocity vector at 0 will be 0, 1. So the velocity, the way x is changing is 0, so it's not going left or right at all. But the y component is just 1. The velocity vector at when time t equals 2 is 4, 1. So the x component is 4, and then the y component is 1. So it kind of look like that. So that gives you an idea of how it's changing. So the x is changing, I would say, like more or faster than the y. Not sure if that's the greatest way to say it. Okay, the acceleration vector is going to be the same for both of them as 2, 0. So the x is changing at a rate of 2 units, and the y is not changing at all. The way it's changing is going to be the same. So it's changing at a constant rate. So those vectors are both this way. So the magnitude tells you the length. What color could I use? I'm just going to highlight it in red. So that segment is 1 unit long. This one will be the square root of 17 units long. The magnitude of the velocity tells you the speed of the particle. Okay, so I think that's all it said to do, right? Sketch the velocity vectors. Okay. All right, hope this kind of helped. Probably try to do a better job in class and answering questions. So if you have any questions, ask next time I see you in class. And thanks for watching. Bye.